Good evening, everyone.
Good
Good
evening.
evening, everyone. Good evening, Bhavagna. Good evening, Aryan. Yeah, good
Evening,
evening.
sir.
Good evening. All right, so we start now. So we are doing the chapter acid, bases, and salts, right? Yes. Any doubts in the chapter acid, bases, and salts?
No, sir.
All right. So in that chapter, acid, bases, and salts, in the last class, what we had done was some of the questions. Today we'll do the chemicals. Some important chemicals from common salt. Also the effect of pH. All right, we see today the topic pH. See, pH, it's obtained from the word potence. Okay, P stands for potence, means power. Like power of electricity, we say that potential. Okay, potential difference. In the similar way, we determine here the power of acids as potence. Got it? Why P? So its potence means power of hydrogen. The power of hydrogen, that potence. Okay. So pH is measured as potence of hydrogen or power of hydrogen. And it is defined as, so we have a quick revision. pH is defined as negative logarithm of hydrogen ion concentration. So these square brackets which I have made here, these square brackets, they are read as concentration. Okay. So pH, it is a negative logarithm. Logarithm is a mathematical function. All right. So you don't need to go into the depth as you don't have any numericals regarding these. So you just have to see what pH is. So pH, it represents or it means the power of hydrogen ions. Okay. So what is the power of hydrogen ions? On this basis, we can find out the strength of an acid or the strength of a base. Okay, so pH means the power of hydrogen ions. Now, as discussed, all the acids and bases, okay, so all the acids and bases, they give out H plus ions or they give out hydroxide ions. For example, HCl, it dissociate to give H plus ions, hydrogen ions, and the chloride ions. All right, but it doesn't happen directly. It will happen only in presence of water. And when this happens in presence of water, so you can see separately that HCl provides H plus ions and chloride ions, and water also dissociate here. So H2O, it dissociate to give H plus and hydroxide ions. So in the solution, you can find out H plus ions as well as the hydroxide ions. So both the hydrogen ions as well as the hydroxide ions are present in the solution. But if you see the quantity of the H plus ions will be higher, or the concentration of the H plus ions will be higher than the hydroxide ions. So, and therefore we'll call this HCl as an acid. Okay. Similarly, if you take a base like NaOH, so NaOH will disintegrate into or dissociate into Na plus and the hydroxide ions. Again, this will happen in presence of water. So in presence of water, this NaOH dissociate. So water gives us H plus and the hydroxide ions. Right. So as we can see here that both HCl and NaOH, they both are providing H plus ions as well as the hydroxide ions. Both are obtained over here. But the hydroxide ions, uh, in both of them, in both, see, when you are dissolving sodium hydroxide, then you are getting H plus ion also. And when you are dissolving HCl, then you are getting hydroxide hydroxide ions also in the solution. Okay. The first one is being acidic in nature, the second one is being basic in nature. Understood these terms?
Yes, sir.
Okay. So now pH is represented as negative logarithm of hydrogen ion concentration. So hydrogen ion concentration will be represented like this. So the value of pH, I'll tell you why the value of pH, it ranges from, the value of pH ranges from 0 to 14. On a scale of 0 to 14, we can measure the pH. The pH scale ranges from 0 to 14. So it's 0, this one is 14. And we mark the neutral point over here. Neutral point is the point where we see both acidic as well as basic behavior. So this is neutral point 7, which you can say it's neither acidic and nor basic. All the substances which will have uh, the substances which will have pH less than 7, they will be acids, and the substances which will have pH greater than 7 will be the bases. Okay, so the strength of an acid, it increases as we move towards 0. So for example, suppose you want to find out the pH of, or this, let's say, you want to compare the strength. You are given the pH equals to 3, pH equals to 5, and pH equals to 9. Okay. So which one of them will be a stronger acid?
pH equals to 3, sir.
Yeah, pH equals to 3 will be a stronger acid. As a smaller value of pH, smaller value of pH means high amount of H plus ions. Okay. So therefore it is okay, it's an acid. And the substances which have their uh, pH greater than 10, greater than 7, they are the bases. The pH greater than 7 is a base, pH uh, less than 7 is an acid, pH equals to 7, that's neutral. Okay. Then we have done pH in our everyday life. So some of the questions you may get from here. pH in our everyday life. We get here pH. Okay. So in our life, where all do we see the role of pH? Very first place we observe is the pH of soil. So what does the pH of soil should be? Should it be acidic or neutral or basic?
Neutral.
Neutral. So a soil, for the proper growth, the soil should be neutral in nature. So pH of soil should be neutral in nature. If suppose sometimes the pH of the soil decreases, so what will you do? What is added? What is done in that case? If the pH of solution decreases, so what is done in that case?
We add base, sir.
Which base generally?
Sir, calcium, I guess, sir.
Yeah, we add calcium oxide. Okay, so calcium oxide or quicklime is added, or a solution of calcium oxide, that is calcium hydroxide, is added to the soil. Okay. so that the soil regains its nature. It still becomes neutral. Got it? So soil requires a pH of 7 to grow. Similarly, in life we also see pH as a factor. It is used by some insects. Used by some insects and animals. So some of the insects and animals do use this property. So of the insects and animals, they do use this property. Alright, for example, the honeybee, they use their stings, and their sting contains an acid. Right, so these are some of them. Scorpion, alright, it also has sting. Its sting also has some acid in it. So understood this why the acids are so powerful?
Yes, sir.
Okay. Then it is used by some of the insects and animals to destroy the other animals. Okay, that is their use. And we also use this pH in our pH is a region for tooth decay. So let it tooth decay. How is decay affected by the pH? Yeah, how is the pH affected by the tooth decay?
Can you repeat the question?
Hmm? Okay, see, when the tooth decay occurs, right, when the tooth decay occurs, it is the bacteria which releases acid. And when acid is released, that acid reacts with the uh, calcium phosphate. Okay, the acid reacts with the calcium phosphate. Got it? Calcium phosphate is the chemical which we call as the enamel, of which our tooth is made up of. So when it reacts with that, then a lot of tooth decay occurs. So first of all, a small amount of first a small cavity is created by the bacteria, whatever bacteria, if some bacteria or food particles, some food particles reside in our mouth. So that food particles, they are converted to acids. Those acids, they react with the tooth enamel and therefore create a cavity in it. When the cavity is created, then it leads to increase in the number of food particles which get stuck over there. Over a period of time, more and more acids are released, therefore causing more and more tooth decay. And understood what is the reason behind tooth decay?
Yes, sir.
Okay, is there anything which is up to here we have covered but you don't know? Anything regarding this? Okay, so the next topic you have here, the pH is tooth chloralkali process. The chloralkali process. It is the process. Rijwana, can you tell what is the chloralkali process?
Sir, it's the process in which we take brine solution and after passing electricity through it, we get chlorine, hydrogen gas.
Okay. So with the chloralkali process, we take brine and that brine is, we take brine over here, and that brine is electrolyzed. Mm. All right. So the solutions which we take over here, we take here brine solution. Aryan, what is brine?
Sir, it is the aqueous solution of sodium chloride and water.
Okay, so it's a brine, it's concentrated solution of sodium chloride in water. It's sodium chloride 30 to 40%. 30 to 40% sodium chloride in water. Then, okay, what are the products of this? What are the products that we obtain over here? Bhavina, what are the products that we obtain here?
Sir, hydrogen gas,
Hmm.
uh, chlorine gas.
Okay, hydrogen, chlorine, all right, and
Sir, I do not remember the last one, sir.
got it. What is the other one? You get caustic soda, sodium hydroxide in the solution. Okay, so these are the three main products which we obtain from the chlor-alkali process. At which electrode do we obtain hydrogen gas? Aryan, at which electrode do we obtain hydrogen gas?
Cathode.
Cathode. Okay, which one is cathode? Positive or negative?
So negative.
Negative. Right.
H plus
So
and cathode.
this is minus, this is plus, this is minus. So you will obtain hydrogen gas over here. So this is a negative one. Here you obtain the hydrogen gas, and here you obtain the chlorine gas, obtain sodium hydroxide. All right. Now these products, they have a number of uses. Can you tell me, Rijwana, can you tell me any two uses of hydrogen? Any two uses of hydrogen? All right. So hydrogen is used in number of, for a number of purposes. We use hydrogen gas as a fuel. So hydrogen is used as a fuel as it has a high calorific value. So therefore we use hydrogen over there. Then fluorine. It is used in making of the bleaching powder, or also it has disinfecting purposes. Sodium hydroxide, it finds a wide variety of use. It's sodium hydroxide. It is used in the formation of, first of all, it's a strong base, and then it is used in the formation of sodium hydroxide. That one, washing soda. All right. So this was from the chloroelectric process. Now we look up at the different chemicals which are obtained to us. So we'll see today the different chemicals. Different chemicals from common salt. Right. So what are the different chemicals that we obtain from common salt and other chemicals also that we are getting? So we'll be listing out, we'll be studying each of the chemicals. The first chemical which we obtain here is washing soda. Okay. Now washing soda, it has the general formula Na2CO3 dot 10H2O. So this 10H2O, it is called as the water of crystallization. There are 10 molecules of water of crystallization present over. Alright. So 10 molecules, you have 10 molecules of water of crystallization present, which can be obtained as clearly seen that it's formed by the crystallization process. So you just need to perform the crystallization and obtain uh, from sodium carbonate, you can obtain 10 molecules of water. Now, these 10 molecules of water, they are called as water of crystallization. So, not only this, there are other salts also which have the water of crystallization. So, Bhavagna, can you tell me what are the other molecules which have? Can you see for the crystallization process? I wanted some of the names from your side other than this. Okay, which uses in which there are crystals. There are pairs sorts of that crystal.
Plaster of Paris.
Salts, sir, but I know other two of them.
Okay,
Gypsum.
gypsum, very good. And
So calcium sulfate. Hemihydrate.
calcium sulfate.
Hemihydrate, that is plaster of Paris.
Okay, CaSO4 dot half H2O, and this is POP, or plaster of Paris. Then the next one,
Gypsum.
gypsum, and formula for gypsum is CaSO4 dot 2 CaSO4. Just a minute. Gypsum. So gypsum is CaSO4 dot. How many water of crystallization are there? 2H2O. So when this is heated up, it gives CaSO4 dot 2H2O is obtained as the water of crystallization over here. So understood this all of them? Alright. So what temperature? CaSO4 dot 2H2O getting it gets converted to CaSO4. Then, okay, so we just now move on to the washing soda again. We'll quickly revise the uses. So, Babagna, what do you think is the washing soda? What is washing soda?
Sir, chemical formation.
Yeah, what is washing soda?
Na2CO3 dot 10H2O, sir.
So, we are I'm asking you uses. What are the uses of washing soda? What are the uses of washing soda?
Removal of permanent hardness of water, sir.
Okay, for the very first use we can say that it is used to remove permanent hardness of water. Very good. And to remove permanent hardness of water and
Textile industries, sir.
okay, what do we use in textile industry for? Okay, so it has cleansing properties, therefore it has cleaning action. So you can say it has cleaning action. So due to the cleaning action, it is able to clean the different substance. Washing soda, it is used as a cleaning, it shows cleaning action. Then any other uses, it is used in glass and paper industry. Glass and paper industry. Okay, so what are its uses in the glass and paper industry? In the glass and paper industry, sodium carbonate is used to obtain more glass or for the manufacturing of glass. Right. So see some questions based on this. For whatever we have learned, we'll just see some questions. So just give me 1 minute. I'm taking out the questions for this. The questions are currently not available. We'll complete with this. So after this washing soda, you have baking soda. How do you manufacture the baking soda? Yeah, how do you manufacture baking soda?
Na2CO3, sir, uh, NaCl plus H2O plus CO2 gives Na2CO3 plus NH4Cl.
Okay, just so I was just searching for your that, but it's not there. It will take longer time. Next is washing soda. So manufacture of washing soda Mhm. Sorry, it's here. It's all right. So the next one is washing soda. So for the washing soda, after washing soda, our next substance is okay. This was washing soda. So apart from the washing soda, we have the other substances like we have a bleaching powder. So can anyone give me an idea how to manufacture this bleaching powder?
Sir, it is the action of chlorine on dry slake lime.
Picture of
Action of chlorine on dry slake lime.
okay action of chlorine on dry slaked lime. It gives us bleaching powder, right? This was the bleaching powder. See, bleaching powder, its chemical formula is CaOCl2 and its name is calcium oxychloride. Calcium oxychloride. What is it? And its common name is bleaching powder. So it's manufactured by passing chlorine gas over bleaching powder CaOCl2. Yeah, it's manufactured from calcium hydroxide, CaOH whole twice. When chlorine gas is passed through it, it gets converted to calcium oxychloride, CaOCl2. You can obtain your H2O. Got this? How the bleaching powder is made?
Yes, sir.
Okay. So tell me now some questions based on this. Or then we can see next chemical. Next chemical over here is mm we have already done baking powder. Okay, baking powder. Yeah, baking powder we haven't done. So how is baking powder manufactured? Okay, baking soda. How is baking soda manufactured? See, baking soda it's manufactured from these four products. Yeah.
Sir, NaCl
Mm.
plus H2O plus CO2 gives Na2CO3 plus NH4Cl.
Okay, just retell a reaction. Can you tell again?
Sir, NaCl plus
Mm.
H2O
Mm.
plus CO2 gives no, Na2CO3 plus NH4Cl.
Okay, so you have ammonium hydro, ammonium chloride also you have.
Yes, sir.
Yes, so you have ammonium chloride and what else is there? Ammonium chloride plus hydrogen, that is water, plus chlorine plus, oh no, chlorine is to be added extra, it's already there. So ammonium chloride plus water. Okay. So ammonium chloride and water, it will produce some flames out of it. Why the flames are there? Can anyone answer why the flames are there? Mhm. Mhm. Yeah. Rijwana, can you tell how to manufacture baking soda? Hello. 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 Rijwana.
Yes, sir.
Yes, sir.
Okay. So Aryan had told how to manufacture baking soda. Rijwana, can you also tell? Rijwana, can you tell how to manufacture baking soda? See, that is a very important reaction. What are the products required? What all do we require? What are the raw materials required for this process? Aryan, what are the raw materials?
Sir, baking powder.
Baking powder. Okay, and
Yes,
baking
sir.
powder. Yeah, so how are you manufacturing the baking powder?
Sir, for baking powder, no, sir. Uh,
Mhm.
and sir, it will be baking soda. No.
Mhm. So how do you manufacture the baking soda?
Sir, sir, baking soda is NaHCO3, no, sir. Sir, we will NaCl plus
What are the raw
NaCl plus
materials?
H2O plus CO2 gives
Okay,
NaHCO3 plus NH4Cl, sir.
very good. First, you remember the raw materials that are there. All right. So the raw materials which are there, they are sodium chloride, common salt. You obtain water, carbon dioxide, and is there anything else?
That's it, sir.
Nothing. Ammonia. We use ammonia. So this leads to the formation of ammonium chloride plus Na2CO3, NaHCO3. So NaHCO3, sodium hydrogen carbonate, it is sparingly soluble in water. Sparingly means it is lightly soluble in water. All right. So this is the reaction for the manufacturing of baking soda. This is our baking soda. Remember, baking soda is a basic salt. Okay, as its basic radical is stronger over here. All right. Bye everyone. We'll continue with revision in next class. We'll continue with revision on Wednesday. See you again on Wednesday. Thank you.